Welcome to the Deep Dive. If you're preparing to architect the next generation of autonomous business systems, you know that Salesforce's Agentforce platform is really where the enterprise is headed. Today, we are undertaking a critical, deep technical dive. It's designed specifically to solidify your knowledge for the Agentforce specialist certification. So our mission is pretty laser focused. We are extracting the essential knowledge and the architectural insights from the source material. We're giving specific weight to that foundational 20% data cloud domain, and also that conceptually challenging multi-agent interoperability section. We need to understand not just what the components are, but how they interact, how they're secured, and of course, how you govern their deployment.
That perspective is absolutely crucial. I mean, we're moving beyond simple automation here. Agentforce represents Salesforce's fully integrated AI platform for creating truly autonomous agents. You can think of them as digital coworkers that execute specific tasks, manage data, and make these context-driven decisions independently.
And we are seeing this transformation accelerate.
We are. The CRM is no longer just a system of record. It's really becoming an autonomous operating system for the entire business. And the ability to scale AI strategically to deploy agents that can handle these complex workflows from end to end, that is the differentiator right now. And Agentforce is the engine underneath it all.
Okay, so let's unpack that foundational definition. When we talk about Agentforce, we are talking about the platform for building and deploying these autonomous agents. Now, what makes them so powerful is their native integration. You said they're not just bolted on. They work seamlessly with Sales Cloud, Service Cloud, Marketing Cloud, and Commerce Cloud. Why is that native integration so architecturally significant?
Well, it allows for genuine end-to-end automation, but without the integration overhead you so often see in legacy systems.
Right.
I mean, if an agent needs to update a Sales Cloud opportunity, then send a Marketing Cloud email, and maybe process a Commerce Cloud return, it handles that entire flow natively right inside the Salesforce environment.
And the benefits are tangible, right?
Oh, absolutely. They're measurable. These agents, they run 24/7. They accelerate business processes, which means, more tasks get done faster without demanding more human agent time. And the sources indicate they can reduce response times for customer inquiries by up to 30%. They can really tackle those complex workflows that were just previously too fragmented or too dynamic for the traditional automation tools.
That brings us to the core of the intelligence. If these agents are truly autonomous, they need a decision-making mechanism that goes far beyond, simple if-then logic. So what is that cognitive core? What's driving Agentforce's decision-making?
That would be the Atlas reasoning engine. This is the brain of the operation, really. It's responsible for managing the entire life cycle of an agent interaction. Think of it as the ultimate orchestrator.
It's the orchestrator, okay.
So when an agent gets an input, a user request, an email, even a platform event, Atlas steps in. It manages the agent's defined role, the communication channel it's using, the whole set of actions available to it, and the mandatory ethical and compliance guardrails. And crucially, its data access protocols.
So if a service agent gets a really complex request, like, I need to return this item, but I want to use my loyalty points for the replacement, and, oh, by the way, my shipping address changed last month, Atlas is the one that has to deconstruct that intent and build a plan.
Exactly. The underlying large language model, the LLM, it identifies the user's intent. But it's Atlas that takes that intent and then determines the best sequence of actions. Should it invoke a flow to update the address? Should it query Data Cloud for the loyalty balance? Should it call an external API for logistics? Atlas orchestrates all those tools, executes them in the correct order, and then it formats that final cohesive conversational response for the user.
Right.
Now, here is a foundational technical point for architects to really grasp. Autonomous agents are inherently non-deterministic. And this distinction from traditional, say, flow or apex logic is absolutely vital.
Non-deterministic. Okay, that's a word that makes traditional developers a little bit nervous. They're used to predictable, rule-based execution. What does that actually mean for Agentforce?
It means that while the outcome will usually be the same, the task gets completed, the exact path the agent takes to get there can vary slightly, even with identical inputs. Unlike a rigid rule that always triggers action A and then action B, the LM's reasoning might subtly shift its internal process. It could be based on context or some nuance of interpretation.
And that leads to variations.
Yes, variations in the exact order of internal calls, or maybe just the phrasing of the response. This variability means you absolutely cannot assume the agent will behave the same way every single time, which is why, we'll later dedicate so much attention to continuous post-deployment monitoring and outcome-based testing.
That makes perfect sense. The AI is generating a dynamic plan, not executing some piece of static code. So let's distinguish between the two major categories of AI agents, because choosing the right type has to be the first step in any solution design.
Right. So we distinguish them based on their level of autonomy. First, you have your assistive AI agents, which you probably know as copilots. These are not autonomous drivers. They're more like support systems. They augment human capabilities by providing real-time recommendations, surfacing contextual insights, and generally helping the human agent make faster, better decisions.
So they enhance productivity, but they don't take over.
Exactly. They don't automate the entire workflow.
And then you have the true automation engines,
Right.
the autonomous AI agents.
Right. These are the agents designed to operate entirely independently. They handle the full end-to-end task cycle without needing any human intervention. They process complex user inputs. They retrieve data dynamically, often grounding themselves in real-time information from data cloud. And then they execute these sophisticated workflows based on deep business logic. They represent that shift from assisted processes to truly independent operations.
And Salesforce organizes these autonomous agents by function. Can you detail some of the specialized types for us?
Sure. We categorize them largely by the cloud environment and the business function. So you have the Agentforce sales agent. It focuses entirely on enhancing sales productivity across the whole funnel. And this includes two key subtypes. First is the Agentforce SDR, the sales development representative. It's designed to manage the top of the funnel by automating tasks like, initial lead nurturing, qualification, and scheduling.
And the other one?
Then you have the Agentforce sales coach. This is a higher level, more bottom of funnel agent. It supports human sales reps by providing deal-specific feedback, summarizing key account activity. It can even facilitate role-playing scenarios to practice objection handling.
So it's about optimizing the human component.
Exactly, optimizing the human part of the sales process.
And on the service side, what do we have there?
For service, we have the Agentforce Service Agent, which is mission-critical for customer experience. Its job is to ingest incoming cases from all the different channels, autonomously resolve the common, well-documented inquiries by accessing the knowledge base, and then intelligently escalate the complex, unique, or sensitive requests that really require human empathy or some specialized handling.
And finally, there's an internal-facing agent as well.
That's right, the Agentforce Employee Agent. This agent supports employees across the organization with internal tasks, things related to general sales enablement, HR inquiries, or common IT topics and actions. It's basically about streamlining administrative and internal operational workflows inside the CRM.
Okay, moving to security. This feels important. If these agents are autonomous and they're capable of writing back to the CRM, creating records, updating opportunities, the security model has to be incredibly robust. How do we make sure that an agent adheres to the principle of least privilege?
Security is implemented through permissions and access control, and it mirrors the traditional Salesforce approach, but it's applied to a special agent user record. First, for any administrator or specialized developer to even create an Agentforce employee agent, they must have the Manage AI agent's permission. That's the gatekeeper.
Okay, that's for the human creating it. What about the permissions for the agent itself to execute actions?
So the agent operates under the identity of an agent user record. This record has to be assigned a permission set that includes two non-negotiable prerequisites, the Einstein agent license and the Einstein agent user profile. That combination is what activates the agent's ability to act. And this is where that principle of least privilege becomes so critical. We have to treat this agent user record like a high-stakes integration user. Its permission set needs to be meticulously restricted, granting access only to the necessary objects, fields, and crucial operational permissions. For instance, if the agent's actions involve manipulating data through flows, that agent user has to have the run flows permission explicitly enabled, but nothing more than what is absolutely required for its defined role. Over-permissioning an autonomous agent sounds like a massive security risk.
It is a significant security risk.
That security discussion leads us logically to the data foundation. Let's shift our focus entirely to Data Cloud now. It accounts for a full 20% of the certification weighting, which to me confirms its role as the non-negotiable prerequisite for autonomous operations. Why do we describe Data Cloud as the brain and the backbone of the intelligent CRM, especially in the context of Agentforce? Because context is absolutely everything for an autonomous agent, and Data Cloud provides that real-time context and memory. It's the unifying platform that pulls in data from everywhere: CRM, ERPs, weblogs, IoT devices, social media, And it doesn't matter if that data is structured like in tables or unstructured like in emails and transcripts.
Huh.
It doesn't just store it. It harmonizes it into a single, cohesive, actionable view.
So an agent isn't checking 5 different systems for one piece of customer history. It's just querying Data Cloud, which has already done all the heavy lifting.
Precisely. And this unification process is what allows Data Cloud to activate segments and events in milliseconds. This is the speed that autonomous decision-making demands. Furthermore, for compliance and trust, Data Cloud governs the data. It ensures traceability, it applies access controls, and it maintains regulatory compliance, which is non-negotiable when autonomous agents are interacting with sensitive customer PII.
Before we even get into things like ROG, we have to talk about data quality. What are the key data quality prerequisites that have to be handled in Data Cloud for Agentforce to even be effective?
Data preparation. It's the strategic step that validates the entire AI initiative. I mean, if the data is garbage, the agent will be unreliable. Simple as that. The data feeding Agentforce has to meet 4 criteria. It must be consistent, meaning deduplicated and standardized, no multiple spellings of names or addresses. Connected, available in real time or near real time to make sure decisions are based on the latest facts.
Okay, consistent and connected. What else?
Governed, meaning there are clear rules that dictate who can access it and how it can be used or activated. And finally, enriched. It has to provide contextual data points that fuel deeper decision-making, not just surface-level facts.
The ability of an agent to execute any meaningful action, from checking an order status to initiating a refund, it really hinges on knowing exactly who the customer is. This points directly to Data Cloud's identity resolution.
Identity resolution is the linchpin. Absolutely. Data Cloud uses these sophisticated matching and reconciliation rules to stitch together disparate records, an email address from Service Cloud, a customer ID from Commerce Cloud, a web cookie ID into a single reliable entity. This creates the unified individual profile. And the Agentforce agent relies entirely on this unified individual profile to accurately ground its actions and contextualize its responses. If identity resolution fails, the agent just can't perform personalized or historical tasks.
And for the certification prep, we have to recall that specific configuration limit related to identity resolution rule sets. There is one, isn't there?
Absolutely. When you're configuring how you consolidate those unified profiles within a data space, Salesforce enforces a capacity and governance limit. You're restricted to a maximum of 2 identity resolution rule sets per primary data model object per data space. That's a hard limit that architects have to plan around when they're designing their data governance strategy, especially across different regional or functional data spaces.
Okay, let's move to the mechanism that actually connects the LLM to all this data. Retrieval Augmented Generation, or RAG. This is what makes the agent a specialized expert rather than just a general-purpose chatbot.
A RAG is really the key to enterprise AI trust. Its whole purpose is to eliminate or at least severely reduce hallucinations. Agentforce uses RAG to establish a connection with Data Cloud, pulling in verified, real-time, proprietary company data to ground the LLM's response. This means the agent isn't just generating an answer based on its general training data, it is basing its answer on your company's current inventory or your policy or a specific customer record.
And this allows for real-time activation, which is a massive differentiator.
Precisely. By accessing live data in Data Cloud, the agent can react dynamically to events, like a customer adding or removing an item from a cart, and it can immediately activate smart, context-aware workflows through Flow and Apex. It ensures those workflows use accurate, real-time segmentation data that's provided by Data Cloud. Technically, RA is retrieving both structured records and unstructured documents from vector databases to provide the LLM with the current, pertinent information it needs to formulate the response.
To handle the unstructured side of things, the manuals, policies, internal documents, we rely on Agentforce data libraries. How do those differ from just, say, pointing the agent at a Salesforce knowledge folder?
Data libraries are structured repositories that are optimized specifically for RA and for semantic search. They serve as the agent's curated, trusted knowledge source, which ensures precise and contextual answers. They can be sourced from Salesforce knowledge articles, which is a very common approach, or from uploaded files like PDFs or HTML documents.
Right.
And when you're setting up a library using existing knowledge articles, the architect has to define identifying fields. These are metadata fields, the title, the summary, certain tags, that the retrieval system uses to optimize its semantic search efficiency. But here's a trade-off architects need to consider. While rich, detailed fields like a texturia might contain great context, using them as identifying fields actually slows down the data readiness and indexing process. Efficiency often demands prioritizing more concise metadata fields for identification.
That brings us to the technical necessity of chunking and indexing for these unstructured assets. Why can't we just upload a massive 300-page policy manual and call it a day?
Well, because of the technical limitations of large language models, specifically their token window, a 300-page manual just won't fit. And even if it did, the LLM would struggle to identify the single relevant paragraph inside it. Chunking solves this. It breaks down large documents into small, digestible parts like paragraphs or small sections that fit within the LLM's token limit and are contextually contained. This vastly improves retrieval relevance.
And once it's chunked.
Once it's chunked, indexing is applied. Indexing organizes these chunks, often by converting them into vectors. And it creates this efficient roadmap or searchable index that allows the retrieval system to rapidly and efficiently locate the exact pieces of information needed to answer the user's question without having to scan the entire document.
All right, let's dedicate some time to the search mechanisms themselves. Choosing the correct search type is crucial for maximizing grounding accuracy, and I know the certification often tests the distinction between the three types. Let's start with the basics. Keyword search.
Keyword search is lexical. It focuses purely on finding exact text matches. If a user asks a question, it looks for documents or records containing those literal words. It's highly effective and precise for structured data like finding a specific knowledge article ID or a customer record where you know the exact name. Its weakness is context. If the user uses synonyms, keyword search often fails.
Can you give an example?
Sure. If your policy says refund, but the user types cash back, a pure keyword search might completely miss the relevant article.
Okay, that makes sense. Then we have vector search, which is also known as semantic search.
Right. Vector search is conceptual. It converts both the user query and the document chunks into numerical vectors points in a mathematical space, and it measures the distance between them. This allows it to understand meaning and context, even if the user uses different words or phrases. It's far superior for complex, conversational, or vaguely phrased questions, and for handling unstructured data like long case notes. It finds conceptual similarity, ensuring that cashback still retrieves the refund policy.
And the current architectural best practice that balances both precision and context, hybrid search.
Hybrid search is the fusion solution. It performs both vector search, for that semantic understanding, and keyword search, for lexical accuracy, simultaneously. It then intelligently combines and weighs those results. This is essential for agents that are drawing knowledge from diverse sources, structured CRM records, and unstructured policy documents. By balancing the two, you get highly reliable and robust grounding outcomes, which is why it is the default recommendation for any complex Agentforce deployment.
Finally, we execute these searches using retrievers. Can you explain the difference between individual and ensemble retrievers?
The distinction really lies in complexity and robustness. An individual retriever is simple. It executes a single, defined search against one specific index or data source with one set of parameters. You can think of it as a specialized tool for a specialized job.
Okay. And the ensemble retriever.
The ensemble retriever is a major architectural step up. It's not one tool, but a collection of individual retrievers that execute their searches simultaneously, potentially against multiple indices, say, one for knowledge, one for case history, and one for a product catalog. The critical step is that the system aggregates all the results from these parallel searches and then subjects them to a specialized re-ranking process. This re-ranking ensures the final set of information presented for grounding is the most relevant possible, maximizing robustness and precision, especially in complex environments where the necessary answer is distributed across several disparate data sources.
Okay, let's move on. While interoperability only accounts for about 5% of the exam, it addresses a fundamental architectural challenge. How do you scale agents beyond just fragmented silos? If we want truly complex, multi-step workflows, level 4 agentic maturity, as they call it, agents have to communicate and coordinate effectively, and that means standardized protocols.
Absolutely. The moment an agent needs to delegate a task or consult an external system, standardization is necessary to ensure both security and predictability. Salesforce supports two major protocols for this scaling effort: the Model Context Protocol, or MCP, and the Agent-to-Agent Protocol, A2A.
Let's start with the Model Context Protocol, MCP. What's its core function? Who does it connect?
MCP is focused on agent-to-tool communication. It's an open standard that defines how AI models connect securely with external enterprise systems, applications, and tools. Its primary purpose is to allow Agentforce to execute real-world tasks that exist outside the confines of the Salesforce database.
So a practical use case.
Sure. Think about an Agentforce sales agent that needs to check current inventory levels. That inventory is probably managed in an external ERP system. MCP provides the standardized, secure interface for that agent to communicate with the ERP tool. This is why MuleSoft's Anypoint platform is so heavily involved here, as it allows developers to expose any MuleSoft-managed API as an MCP server. It securely extends Agentforce functionality without requiring complicated custom integrations.
Okay, so MCP is about actionability and connecting to systems. Now let's look at the agent-to-agent protocol, A2A. This sounds like the standard for agents to talk to each other.
That's exactly right. A2A defines how AI agents, whether they're in the same organization or operating across organizational boundaries, can communicate, coordinate, and delegate tasks. It provides a standardized, interoperable framework for exchanging messages, which makes the overall workflow resilient, regardless of the agent's underlying platform or vendor.
And Salesforce has a specific contribution to the A2A specification related to trust and governance, right?
Yes, the agent card. Salesforce contributed this concept to the A2A specification. You can think of it as a lightweight JSON contract. When one agent is considering collaborating with another, the agent card is exchanged. It contains essential metadata: the agent's identity, its specific capabilities, its compliance tags, and most importantly, its trust score. This trust score is what enables robust decision-making about delegation and risk assessment.
And how does this work architecturally?
Architecturally, within Agentforce, we use standard event-driven communication. This means that platform events form the secure and scalable transport layer for all A2A collaboration.
Let's try to solidify the difference with a practical scenario. Say a customer service agent receives a complex product return request.
Okay, in that scenario, the service agent might use A2A to communicate with an external return specialist agent, delegating the complex logistical task based on the returns agent's capabilities defined in its agent card. Simultaneously, that same service agent might use MCP to consult an external logistics API, which is a tool managed by MuleSoft to check shipping costs or track the inbound package. Both protocols are necessary for that kind of multi-step coordinated action.
And Data Cloud plays a role here too, I assume.
It does. This is where Data Cloud circles back. Even though agents are collaborating externally, they have to operate off the same factual context. Data Cloud ensures both the service agent and the return specialist agent are sharing the same unified real-time customer and inventory knowledge base. That prevents conflicting actions or inconsistent customer information being relayed.
Now, let's talk about integrating Agentforce intelligence into external applications completely outside the Salesforce UI. This is where the Agent API comes in.
The Agent API is a standard REST API interface. Its purpose is to enable external systems like custom web portals, embedded mobile applications, or headless automation processes running on a server to invoke Agentforce agents programmatically. It's best suited for when you need to embed Agentforce intelligence into non-Salesforce UIs or manage large-scale automated interactions, all while ensuring consistent intelligence and context.
This integration requires a very specific, and I know it's often tested, security configuration involving a connected app. Why is this setup so meticulous, and what are the crucial scopes needed?
The security setup has to be rigorous because the external system is acting on behalf of a user, potentially in a headless environment, and it needs persistent session access. Access requires setting up a connected app that supports the secure client credential flow, or any flow that provides a JWT-based access token. Then this connected app must be explicitly authorized and added to the Agent's Connections tab as an API connection.
And the scopes. There are 4 of them that are critical.
Yes, 4 specific OAuth scopes, and they are critical and non-negotiable for full functionality in a headless scenario. First, access chatbot services, Chatbot API. This is the fundamental scope allowing the external system to interact with the agent's core services. Second, access the Salesforce API platform, SWAP API, which provides generalized access for the underlying infrastructure.
And the other 2.
Third is manage user data via APIs, API. If the agent is reading or writing standard CRM records during its process, this API access is mandatory. And fourth, perform requests at any time, refresh token, offline access. This is arguably the most critical for headless or long-running automation. It allows the external application to maintain consistent intelligence and refresh its token without continuous re-authentication. If this scope is missing, long-running processes or sessions will just time out, breaking the headless automation.
Okay. Moving to our final major domain, the development lifecycle, which also holds a 20% weighting. Once an agent is designed, secured, and grounded in Data Cloud, quality assurance and governance become paramount. Let's start with how we test these non-deterministic systems using the Agentforce Testing Center.
The testing center is a vital tool for achieving efficient quality assurance. Since we can't test every single permutation of a non-deterministic agent, we test outcome probability at scale. Its primary function is to allow developers to evaluate a large batch of user inputs or utterances in a single, streamlined batch test. This drastically reduces the overall testing time compared to manual interaction.
So what does an architect need to know about setting up and running a successful batch test?
Well, the process starts by preparing a CSV file that contains the diverse test cases, the utterances, and the expected outcomes for each. The test must be run in a sandbox environment. This isolation is crucial to prevent any unintended modifications to live production CRM data, given that agents can execute transactions. After the run, the architect analyzes the results, specifically focusing on the failure points, where the agent misidentified the intent, failed to ground the response correctly, or executed the wrong action, and then uses that to fine-tune the instructions and logic.
And there are some practical considerations like costs and limits, right?
Yes. Two details are essential for managing this process. First, resource consumption. Running these batch tests consumes both Einstein requests and data cloud credits. This is because every single test case utterance triggers the LLM and often initiates RAG calls, hitting the vector database. Monitoring this usage is necessary to avoid unexpected cost spikes. Second, the testing center has hard limits. You can run a maximum of 10 tests within a 10-hour time frame, and each individual test is capped at 1,000 test cases. Architects have to manage their testing cycles to stay within those parameters.
You touched on RAG and data cloud credits. That brings up the critical issue of data parity during testing. If the test is supposed to validate grounding accuracy, the data environment has to match production, doesn't it?
Absolutely non-negotiable. If the data library, the unstructured knowledge base used in the sandbox, is not a true replica of the production knowledge base, then any testing related to our grounding is essentially meaningless. Data parity means ensuring the sandbox has representative customer data, configuration metadata, and a complete up-to-date data library that mirrors the live environment. If your test confirms a high grounding accuracy in a sandbox, but that sandbox is missing a critical set of policy documents, the agent is going to fail in production. So once testing validates the agent's behavior, we move to deployment from sandbox to production. What are the metadata and architectural considerations here?
The deployment itself utilizes standard Salesforce lifecycle tools, change sets, or the metadata API. However, you have to meticulously ensure all the relevant components are included in the deployment package. You must include the Genet Planner component, which defines the agent's logic, the Einstein bot definition itself, and the specific bot version that has been fully validated.
And there's often a practical component for service agents. Right, a frequent practical necessity. If you are deploying a service agent that lives on a digital channel, you will often need to include the embedded messaging component if that agent is going to be hosted within an Experience Cloud site or an external web page.
Given that we've established these autonomous agents are non-deterministic, what does that mean for the deployment architecture? How identical do the environments need to be?
They must be near identical. Because the reasoning engine is so dynamic, any subtle difference in the environments can cause the agent's behavior to diverge dramatically. This requires far more synchronization than deploying a standard flow. Environments must be identical in both data and metadata, including sharing settings, flow, and Apex versions. Any missing permission or different configuration could prevent a critical action from executing, leading to an unpredictable production failure that you never saw in the sandbox. And of course, post-deployment, you have to remember the simple but crucial final step. The agent must be explicitly activated in the agent builder to begin processing requests.
Okay, finally, post-deployment. How do we manage and monitor agent adoption and measure its continuous improvement?
Monitoring is really a dedicated cycle of tracking interactions, gathering feedback, and analyzing usage metrics. Agentforce Analytics provides the standardized dashboards and reports you need for operational insights into usage, overall adoption rates, and user feedback.
And for performance optimization?
For performance optimization, the Utterance Analysis dashboard is the architect's best friend. This dashboard specifically tracks user engagement. What are users asking for? How are they phrasing their requests? And most importantly, how effectively is the agent handling those specific requests? This immediately identifies any gaps in the agent's knowledge or planning logic.
And when you need to do a really deep troubleshoot, say, tracing why one specific complex interaction failed.
For that kind of detailed, granular investigation, the specialist utilizes the event logs, which are found right within the agent builder. These logs provide a detailed, traceable record of every step of the user interaction and the Atlas Reasoning Engine's internal decision-making process. This level of logging is essential for optimizing the user experience and resolving those elusive, intermittent issues that arise from the agent's non-deterministic nature.
We have successfully navigated the entire life cycle, from the architectural core and security to the data cloud foundation, the requirements for interoperability, and the rigorous testing and governance processes required for autonomous agents.
That really summarizes the necessary expertise for the specialist role. We've established that Agentforce enables scaling operations, but that capability is entirely dependent on it being securely and accurately grounded in Data Cloud's real-time context.
So to recap the key architectural pillars for everyone listening, Data Cloud is the non-negotiable context provider. It unifies structured and unstructured data into the unified individual profile, which is the identity the agent uses to personalize actions.
And the technical execution of that grounding relies on mastering a reg, understanding how chunking and indexing optimize unstructured content, and deploying hybrid search as the current architectural best practice. That's what balances the precision of keyword search with the context of semantic search.
And finally, scaling to multi-agent operations requires standardization. MCP defines the agent-to-tool communication critical for accessing external APIs, while A2A standardizes agent-to-agent collaboration via platform events, relying on the agent card for trust and capability discovery. This is the framework that prevents those fragmented AI silos.
Ultimately, Agentforce represents a system built for continuous optimization. It's powered by data cloud and sophisticated AI models, and the agents are engineered to learn from real-world outcomes, constantly improving their decision-making, reliability, and responsiveness over time.
Before we conclude this comprehensive deep dive, here is one final thought for you to explore as you prepare to implement and govern these complex autonomous systems. Considering the inherently non-deterministic nature of autonomous agents and their ability to execute critical business actions independently, how does verifying the agent trust score, that lightweight JSON contract that tracks ethics and compliance within the A2A protocol, fundamentally change the conventional definition of system quality assurance in a continuously evolving multi-agent environment? You're no longer just testing code against a defined functional requirement, you are assessing continuous judgment and ethical risk in delegation. It's a fascinating architectural challenge.